Alright, now let's see how things change when we start naming alkenes. Alkenes, of course, have a double bond between carbon atoms. We'll do the same thing we've been doing. We'll say, what's the longest continuous chain? In this case, what we're asking is what's the longest continuous chain that includes the double bond. This first example is very simple. There is only one chain. There are only two carbons. Two carbons, of course, has the root F. There it is, F for two carbons. The ending will be ENE. ANE is if it's an alkane, but this is an alkene, double bond, so the name will end in ENE. And as we'll see in these next few examples, usually we need to say, where is the double bond? Where is it in the molecule? But in this case, there's no choice. There are only two carbons, so this is just plain old ethene. Ethene. Here's an example, next one, where it does matter where is the double bond. So let's have a look. Highlight the longest continuous chain. As usual, we will number from the end closest to where the action is. Here's the action. This is the exciting part of the molecule, the interesting part. So I number from the left, carbon 1, carbon 2, carbon 3, carbon 4. Nothing is attached, so I can go at it. 4 carbons, bute for 4. Ene, because there's a double bond. But here I do want to say, where is the double bond? Let me write just underneath this a different alkene. That one. These two molecules are not the same. These are not identical. They each have 4 carbons. They each have a double bond, but where the double bond is matters in this case. Those are different. So I do need to say, where is the double bond? And when I start at the beginning of the molecule, carbon 1, where do I first get to the double bond? Right away, at carbon 1. So I would write that like this, 1-butene. 1-butene means 4 carbons in the main chain. There is a double bond. Where is it? Right here, starting at carbon 1. What do you think the name of this one would be? Let me give you just a moment to think about it. Okay, you'll do what we've been doing. Number the parent chain. Notice in this case, if I number from the left or if I number from the right, I get the same thing. I get that the double bond starts on carbon 2. Look at that. The double bond starts at carbon 2. Bute because 4 carbons in the longest chain. Ene for alkene. This is 2-butene. 1-butene, 2-butene. Not the same compound. These are not the same compound, so they have different names. They need to have different names because they're not the same compound. How about the one right below that? Let's do what we've been doing. Highlight the longest continuous chain. Right there they are. 4 of them. Number from either end, and we'll get the same thing. 1, 2, 3, 4. So this is bute again. And we can see that it's 2-butene again. The double bond starts on carbon 2. Whoops. Double bond starts on carbon 2. But check out what you notice this time. The way that this one is written. This indicates, by the shape of it, this indicates that this is cis. What was shown right there is cis 2-butene. The hydrogens are both pointing in the same direction up. That is cis. Trans would look like this. For this same compound, the trans version of it, which is then a different compound, looks like this. The one that I just wrote in black, that is trans 2-butene. Cis and trans are isomers. We've seen that before. Up here, these are constitutional isomers because the order of bonding is different. These are stereoisomers, and they're a specific type of stereoisomer called cis and trans. Now, I would like to point out, if it doesn't indicate to you what the what's pointing up, what's pointing down, then you're not able to say if it's cis or trans. You can't tell. But if the molecule is drawn in a way that you can see the shape, then you can determine if it is cis or trans. Next one, highlight the longest continuous chain, like so. Number it, as usual. This one, again, it doesn't matter. Left or right, we'll get the same numbers. 6, so this is hex. Hex is 6. I see that it has a double bond, so hexene. Where is the double bond? Take a look. Start at carbon 1 and start marching down the molecule until you get to the double bond. 3. Starts on carbon 3. So it is 3-hexene, and then I look to say, can I tell if it is cis or trans? And I can. Look at the ends of the parent chain coming off the double bond. That's going up. This is going up. They're doing the same thing. Remember that trans is one going up, one going down. Cis is either they're both going up or they're both going down, but they're doing the same. Cis means same, kind of. So this is cis 3-hexene. Cis 3-hexene, and that's a dash. One more. Let's look at this one. Highlight the longest continuous chain. There it is. Number it. And I'm going to double check. 1, 2, 3. Oops. Longest continuous chain. Highlighted it. Numbering. If I number from the right, 1, 2, 3, the double bond would start at carbon 3. If I number from the left, 1, 2, 3, same. So it doesn't matter which direction, which end I number from. I see that it is 6, so hex. I see there's a double bond, so hexene. I see that the double bond starts at carbon 3, so 3-hexene. And what do you think here? Does this look like cis or trans? Sometimes if it's hard to tell, see how that double bond is slanting up? Sometimes I like to do this. Rotate the paper just a little bit so that the double bond is sideways, like straight across. For some reason that's easier for me to see. Then I can show, oh, look, that goes up, this one goes down. If I'm at either end of the double bond, one's going up, one's going down. They're doing the opposite. Here they were doing the same. That was cis. They're not doing the same. They're opposite, and so that is trans. Trans 3-hexene. And there you have it. There's a number of alkenes. These didn't have anything branched off. These are plain alkenes, nothing branched. In the next video, we'll see how to handle it when there are groups branching off.